This video is going to discuss how to solve a 3-variable system by any means necessary, whether it be substitution, whether it be elimination, whatever the methods are. This is the last video in the installment of systems of equations. So if you notice, the last 2 videos we talked about, we had 2 equations. We had whether one was solved for y, or when neither of them were solved for y, or x, or whatever. We use elimination or we use substitution. If you notice here, we now have a system with 3 variables. Remember I said the definition could be 2 or more, so this one has 3. When it was just 2 equations, we were dealing with a line. So I graphed a line, I had another line, I found out where they touch. When we're dealing with 3 equations, we're dealing with what we call planes. Remember, a plane is something that goes on in all directions, but it has no thickness, right? So it goes up, down, left, right, in all directions, okay? So north, south, east, and west, but it has no thickness. So each of these equations represent a plane in 3-dimensional space. If we were graphing them, we would find the intersection of planes. We would find the intersection of planes, where 2 equations, we found the intersection of lines. So the main goal we have here is trying to identify where these planes touch, okay? Now, we have an R, an S, and a T. How does my answer get written? Well, my answer gets written using now a 3-ordered pair, and this is R, S, T. How do I know where they go, R, S, or T? How do I know R goes first? Well, it goes first because it comes first in the alphabet. Whatever comes first in the alphabet goes first in an ordered pair, or an ordered triple, if we want to call it this. Okay? That's the reason behind why I put R first, S in the middle, and T in the last. That's the same reason we put X and Y. It's not YX, it's XY because it comes first. If we just want to think of it that way, it's always going to work. So now, I want to have these 3 variables, and I want to start canceling them if I can. If I look at my R's look like they're pretty close to being canceling right now. So what I'm going to do is I'm going to take the first one here and the second one here, and I'm going to add them together. Because I add them, my R's are going to give me 0. 1 minus 1 is 0. So let's add the rest of them. I'm just going to rewrite this so you can see what I'm doing here. R plus S minus T equals -4, and then -R minus 6S plus T equals 24. So because I'm adding these, R minus R is 0R, but because I have a 0R, I don't need to write it. 1S minus 6S is -5 S's. -1T plus 1T is 0T. But again, I don't need to write it. Equals 20. Now, some of you are like, well, what happened to my R's and my T's? They just canceled. Because of the way the problem worked out, they just ended up canceling. So, what do I know? I know that S is equal to -4 already. After the first set of manipulation, S is already equal to -4. Yay! So now what? I still need to find R and T. How do I do that? Well, again, if I look at my first one, R plus S minus T equals -4, and my third one, -R minus S plus 4T equals -11, my R's, if I add them, cancel out again. So that's good. Okay, your goal is to get rid of these 3-variable systems to eliminate a variable into 2 different new equations and then solve what we did prior. Okay, so that's what I'm doing. So R minus R is 0. S minus S is 0. -T plus 4T is 3T equals -15. T is equal to -5. So I know my T value, -5. How do I find my R value? Well, let's take our first equation again. So it's R plus S minus T equals -4. Plug in my S, plug in my T, and solve for R. R plus negative 4 for s minus negative 5 for t equals negative 4. R minus 4 plus 5 equals negative 4. R plus 1 equals negative 4. R equals negative 5. So those three numbers, negative 5, negative 4, negative 5, is the point at which on the three-dimensional axis we are going to get these three equations. Remember, they're planes. We're going to get them to touch. That is the point in space that we're going to get those three equations to touch. Now, this particular problem looks similar to what the last one was. It's still a three-variable system, and again, this video is all about them. The last one was a little easier because if I looked at some of the variables, we were able to just add or subtract basically from the beginning to get rid of some of the variables. So you notice that these two r's here are basically the same, just they're opposites of one another. So I can take them, r minus 3s minus t equals 20, minus r minus s minus 2t equals 9. Because they're opposites, I can add to get 0. So that gives me negative 4s minus 3t is equal to 29. So that equation here that I just wrote does not contain an r. So I want to now eliminate an r from another set of equations. And in order to do that, I have to use now the third equation that I didn't use to start with. I'm going to write that down below just so that I can see it a little clearer. And I need to now use one of these equations to eliminate that r. If I look, this one's a negative, so I don't have to then subtract stuff, I can just add it. So I'm going to multiply this equation by 4. When I do that, I get negative 4r minus 4s minus 8t is equal to 36. If I notice now my r's are opposite signs, one's positive, one's negative, I can add to cancel. This gives me 1s minus 14t is equal to 37. I have an equation here that I just did, and remember the equation from up here. They both have no r's. So I'm going to stack them. 1s minus 14t is equal to 37. Now what I have to do is eliminate one of the variables in these two equations. Well, how can I do that? Well, if I can multiply this bottom one by 4, I get 4s minus 56t is equal to 148. And then the top one is going to remain the same. And now I'm going to add because my s's are opposite signs. So I get negative 59t equals 177. When I divide, I get t equals negative 3. So remember, my ordered pair is really now an ordered triple. And how do I know what goes first? Well, again, variables that come first in the alphabet come first, so it's r, s, and t. So we know t is negative 3. So how do I now go from there? Well, I have an equation here, here, and a new one in blue there that only contain s's and t's. If you notice, the ones in red are exactly the same. I just wrote them in different spots. So I have three equations. I have two in red, one in green, and one in blue. That it is my choice to use one of them. I am going to use this one here because it looks as though the numbers are a little smaller, meaning the s is 1. So that's going to make my life a little easier. So what I'm going to do is plug the negative 3 into t and solve. So s minus 14 times negative 3 is equal to 37. S plus 42 equals 37. s equals negative 5. So we know s is now negative 5. So I have two variables solved for. The third one, I don't know what it is yet, r. Now I'm going to come back to one of my original equations. And if I look, I have the top one, the middle one, or the bottom one that I can use. You can choose either of them to work with. I'm going to choose the top one because r is positive. Again, you can choose the middle one or the bottom one, it doesn't matter. And I'm going to plug in the numbers s and t to where they go. So r minus 3 times s, which was negative 5, minus whatever t was, which is negative 3, equals 20. And now we're going to solve. So r plus 15 plus 3 equals 20. If you do the math, you actually get r is equal to 2. So r is 2. S is negative 5 and t is negative 3. This equation will be the last equation that is being done in this particular video. If you have more questions over elimination or substitution, then just go back and watch those. This equation, or this systems of equations, if I look, none of my variables, x's or y's or z's, are automatically able to be canceled right now by adding. But if I look at the 4y here and the 4y here, those are exactly the same. How can I make those 0? In order to make those 0, what I can do is I can take the signs of the bottom equation and flip them. Basically, that means I'm multiplying by a negative 1. So I'm going to rewrite my equation, my top one. I get negative 2x plus 4y plus z equals negative 16. And then I'm going to rewrite my bottom one after I flip the signs. 6x minus 4y plus 2z equals negative 22. Now I can add them together. 4x, my y's are canceled, no more of them, plus 3z equals negative 38. So this equation that I just wrote has no y's in it. So then what I want to do is I want to eliminate my y's from another set of equations. I have to use this one, the middle one, because I didn't use it first, so I have to use it now. Then let's find out. Let's use the bottom one. And I can even use the bottom one after I changed it to its opposite, after I multiplied by a negative 1. So if I look here, my y's aren't able to be canceled right now, but if I multiply the top one by 2 and the bottom one by 3, I will get 12 and negative 12, which then means I can add together. So let's do that. I get negative 10x plus 12y minus 8y equals 38. And then I get 18x minus 12y plus 6z equals negative 66. You notice my y's cancel when I add. I get 8x minus 2z equals negative 28. I then am going to take the equation I just got and write it underneath the equation that I had earlier. 8x minus 2z equals negative 28. Once I have those two equations with no y's, now I got to eliminate one of the variables there. Which one do you want to do? It's up to you. If you want to eliminate x's or z's, it's your call. I am going to eliminate x's because I can multiply the top one by a negative 2 to give me a negative 8x minus 6z equals 76. You could have eliminated your z's by multiplying the top one by 2 and the bottom one by 3, but instead of multiplying two equations, I got rid of it by just multiplying by one of them. So now I have these two equations here, and I'm going to add negative 8z equals 48. So z equals negative 6. So my answer is going to look like x, y, and z. We know z is -6. Let's write it down. So I have z to be -6, and I have a couple equations with z and x in it. So I'm going to take the -6, plug it into that z, and solve. So 4x plus 3 times, and now -6 with z, equals -38. I get 4x minus 18 equals -38. 4x equals -20. X equals -5. So -5 is now x. Then I have to plug in. Let's plug into the top one. You can plug into the middle or the bottom one. It is up to you. So I'm going to go all the way to the right over here and start writing. So I get -2 times whatever x was, which was -5, plus the 4y, because I don't know what y is, plus the -6 for z, equals -16. Now let's solve. That's 10 plus 4y minus 6 equals -16. So that's 4 plus 4y equals -16. 4y equals -20. Y equals -5. So y is -5. So my answer for this one is -5, -5, -6. This concludes solving a system of equations by elimination or substitution, but it's a 3-variable system. So I have 3 variables, x, y, z, r, s, t, a, b, c, doesn't necessarily matter. If you need help on previous videos, please make sure you tune in for them. I will actually upload one more video with some systems of equations, but some special cases.